The contemporary sky is no longer a vacuum of wind and thrust, but a dense, invisible forest of electromagnetic waves where the silent and the sighted rule. Deep within the classified hangars of Edwards Air Force Base, a mechanical resurrection is occurring as the F-22 Raptor transcends its own legendary physical limits. This is the dawn of the Super Raptor, a fundamental architectural reconfiguration designed to dominate a theater where traditional stealth has finally met its match. Defense analysts characterize this shift as an evolution from a pure air superiority platform into a highly networked, multispectral dominance node capable of systemic warfare. The impetus for this massive undertaking is the sobering realization that the stealth advantage held since the early 2000s is rapidly eroding against modern defenses. Intelligence assessments reveal that the global proliferation of low-frequency radars and multi-static detection networks has compromised the once impenetrable tactical margins of low observable aircraft. In response, the United States Air Force has authorized an immediate $90 million capital injection to operationalize the Super Raptor configuration for the Pacific theater. This strategic allocation signals a profound doctrinal pivot, prioritizing the lethality of the existing elite fleet over the uncertain timelines of sixth-generation platform development. The operational logic is firmly grounded in the Davidson Window, a projected timeframe where high-intensity conflict in the Western Pacific becomes a statistical probability. To grasp the gravity of this upgrade, one must first analyze the gradual degradation of the asymmetric advantage that America held for nearly 2 decades. When the F-22 achieved initial operating capability in 2005, it reigned over a permissive electronic environment with absolutely no near-peer equivalent in the sky. Today, the geopolitical board has reset entirely, with the People's Liberation Army Air Force deploying the Chengdu J-20 inches increasingly significant and threatening numbers. The J-20 is not a mere imitation of Western technology. It is a purpose-built interceptor designed to push American support assets into deep, vulnerable exclusion zones. Simultaneously, the Russian Su-57, despite its production constraints, has introduced advanced sensor fusion concepts that challenge the Raptor's historical ability to remain completely undetected. The Pentagon's reaction is not one of panic, but a calculated engineering masterstroke designed to restore the widening gap in kill chain execution speed and reliability. The strategic necessity is driven by a harsh mathematical reality. The United States possesses only 185 Raptors, with the original production lines permanently shuttered. Every single airframe in the current inventory is a finite strategic asset that must remain relevant until the next-generation air dominance fighter arrives. The F-47, the anticipated successor to the Raptor, remains in the engineering development phase, with its full operational capability still several critical years away. Relying solely on an unproven future platform creates a dangerous capability trough in the late 2020s that adversaries are already being tempted to exploit. Therefore, the Air Force is aggressively backporting sixth-generation technologies directly into the F-22 airframe to bridge this specific and dangerous temporal vulnerability. This integration strategy involves bleeding-edge hardware originally developed for the NGAD program, effectively turning the Raptor into a lethal technology demonstrator for the future. The cornerstone of this modernization effort is the Infrared Defensive System, or IRDS, which fundamentally alters how the aircraft perceives its complex combat environment. Lockheed Martin's $270 million contract focuses on integrating distributed infrared apertures seamlessly around the skin of the aircraft for 360-degree awareness. In the arena of modern aerial warfare, active radar emission is a liability that effectively announces a pilot's position to every receiver in the theater. The IRDS allows the F-22 to detect, track, and engage targets passively, relying solely on the thermal signatures generated by the friction of enemy airframes. This system utilizes third-generation sensing elements capable of discriminating tiny heat signatures against complex background clutter at unprecedented and extended operational ranges. The tactical implication is revolutionary. A Super Raptor can now execute a complete firing solution without ever emitting a single pulse of detectable radar. This capability is essential against modern digital radio frequency memory jammers, which capture and manipulate active radar signals to deceive the attacking fighter. By shifting the primary hunt to the infrared spectrum, the F-22 bypasses the enemy's electronic warfare defenses and strikes from a position of electromagnetic silence. The upgrade also includes new external podded sensors that provide long-range infrared search and track capabilities to complement the jet's internal sensing suite. This comprehensive sensor fusion creates a spherical awareness bubble, allowing the pilot to visualize threats from all directions, including high-velocity incoming missiles. Crucially, this system detects the thermal bloom of a missile launch instantly, granting the pilot vital seconds to initiate sophisticated electronic and kinetic countermeasures. Against long-range weapons like the Chinese PL-15, which targets high-value assets from hundreds of kilometers away, this early warning system is absolutely mandatory. The physical survivability of the aircraft is also being enhanced through the application of revolutionary new low-observable coating materials and advanced application techniques. Aviation observers have recently documented F-22s flying with a reflective, mirror-like skin that differs radically from the standard matte gray radar-absorbent material. These new materials are engineered to reduce the aircraft's signature across a broader range of the electromagnetic spectrum, specifically targeting advanced infrared sensors. Traditional stealth coatings are optimized for X-band fire control radars but offer significantly less protection against high-frequency tracking or modern thermal imaging systems. The new coating technology likely incorporates conductive metal oxides designed to manage skin friction, heat, and effectively scatter incoming laser energy from trackers. This innovation reduces the infrared contrast of the aircraft against the cold background of the upper atmosphere, countering even the most modern IRDS systems. Furthermore, the new material science addresses the chronic maintenance intensity that has historically plagued the Raptor's operational availability and mission readiness rates. By increasing the durability of the stealth treatment, the Air Force ensures that more jets are ready for combat rather than sitting in climate-controlled hangars. Operational availability is a strategic quality of its own. The most advanced fighter is useless if it cannot sustain a high sortie generation rate. Beyond the skin, the F-22's APG-77 radar is receiving dynamic software updates to dramatically enhance its synthetic aperture, radar mapping, and resolution capabilities. This allows for the precise targeting of mobile ground assets, even through adverse weather or heavy smoke, expanding the Raptor's utility in complex strike missions. The modernization also overhauls the ALR-9-4 electronic warfare suite, the hidden backbone of the Raptor's industry-leading situational awareness and threat detection capabilities. Enhanced geolocation algorithms allow the jet to triangulate enemy radar emissions with sufficient precision to cue long-range weapons purely on passive sensor data. This creates a lethal dilemma for the adversary. Activate your radar and be destroyed, or keep it off and fly blind into the engagement. The synergy of passive sensing, broadband stealth, and electronic warfare dominance completely redefines the tactical geometry of modern air-to-air combat. However, detection is only the precursor to destruction, and the Super Raptor's claws are being sharpened with an entirely new class of advanced ordnance. The lethal centerpiece of this reconfiguration is the AIM-260 Joint Advanced Tactical Missile, a weapon specifically engineered to reclaim American air-to-air range dominance. While the specific kinematics of the JATM remain highly classified, intelligence suggests a propulsion system optimizing terminal velocity to extend the no-escape zone. This munition fits precisely within the F-22's internal weapons bays, preserving the clean aerodynamic profile that is non-negotiable for deep penetration stealth missions. This corrects a critical historic deficiency, where carrying external long-range ordnance would instantly compromise the radar cross-section of the airframe to enemy sensors. Recent flight tests have demonstrated the ability to engage targets at ranges previously reserved for heavy, non-stealthy interceptors, restoring the tactical advantage. By coupling the JATM with the new IRDS sensors, the Raptor can execute silent launches from beyond the detection horizon of adversary warning receivers. However, in the vast, unforgiving expanse of the Pacific theater, the tyranny of distance is as formidable an enemy as the opposing air force. To conquer this geography, Lockheed Martin is fielding the low-drag tank and pylon system, a breakthrough in stealth-compliant external store design. These are not standard drop tanks. They are stealth-shaped fuel reservoirs engineered to minimize radar return while significantly extending operational range. The engineering triumph lies in allowing the F-22 to maintain supercruise sustained supersonic flight without afterburners even while carrying these external fuel stores. Upon entering contested airspace, the pylons can be jettisoned instantly, returning the aircraft to its maximum stealth configuration for the terminal combat phase. Yet, kinetic performance is now secondary to the ability to process and distribute battlefield data across a joint multi-domain network. The original F-22 was an introverted platform, designed to receive data but severely restricted in its ability to transmit to other aircraft types. The upgrade program breaks this isolation by installing an open systems architecture that allows the Raptor to function as a forward-deployed sensor node. This facilitates the quarterback concept, where the F-22 designates targets for F-35S and fourth-generation assets to engage from safer standoff distances. This connectivity leads directly to the integration of collaborative combat aircraft, the unmanned systems that will define the future of air superiority. Budget documents confirm that the modernized F-22 is being interfaced to control loyal wingman drones directly from the cockpit in real time. A single pilot will no longer be a solo operator but a mission commander managing a formation of autonomous, expendable systems. These drones act as force multipliers, serving as decoys, jamming nodes, or flying magazines to overwhelm sophisticated enemy air defenses. This manned-unmanned teaming forces the adversary to expend expensive interceptors against lower-cost drone platforms, shifting the cost curve in America's favor. The strategic calculus shifts from protecting every airframe to optimizing the survival of the human decision-maker at the center of the swarm. This layered approach ensures that even if the next-generation air dominance fighter is delayed, the capability gap remains firmly closed. Critically, the timeline for these upgrades aligns with the projected modernization and expansion of the People's Liberation Army Rocket Force. As enemy anti-access area denial bubbles expand, the value of a penetrating counter-air asset capable of hunting high-value support aircraft increases exponentially. Without these force multipliers, the AWACS and tankers, the enemy's fighter fleet loses its eyes and endurance, effectively blinding their offensive capability. The modernization budget allocates over $7 billion through 2030 to finalize these hardware integrations and ensure fleet-wide adoption. This includes the critical retrofit of 32 older Block 20 training aircraft into full combat-coded status, significantly expanding the deployable fleet size. Bringing these additional airframes to the front line provides the operational density required for sustained high-intensity conflict in multiple theaters. The logistical tail is also being streamlined, with predictive maintenance algorithms reducing the turnaround time between sorties to maximize fleet availability. Every hour an aircraft spends on the tarmac for repairs is an hour the adversary gains to consolidate their position in the air. The revitalized logistics chain ensures that the F-22 can generate sorties at a tempo that matches the relentless urgency of modern warfare. This entire ecosystem, sensors, weapons, fuel, data, and maintenance, creates a compounding advantage that is incredibly difficult for adversaries to replicate. While Russia struggles to mass-produce the Su-57 and China iterates on the J-20, the US is fundamentally changing the rules of the game. The F-22 is moving from a static definition of air superiority to a dynamic, evolving capability set that adapts faster than the threat. It is a recognition that hardware dominance is fleeting, but system integration provides a more durable and resilient strategic edge. The pilot's role is shifting from stick and rudder skills to information management and tactical resource allocation in a high-speed environment. In the cockpit of the Super Raptor, the primary weapon is no longer just the missile, but the network itself. This evolution reflects a broader doctrinal shift towards distributed lethality across the entire joint force, from space assets to surface fleets. The adversaries watching Edwards Air Force Base are not just seeing a better jet, they are witnessing a new philosophy of war. The implications for the balance of power in the Indo-Pacific are immediate, forcing a recalculation of risk in Beijing and Moscow. This technological leapfrogging creates a severe dilemma for the People's Liberation Army, rendering their specific counter-strategies obsolete upon deployment. The Super Raptor is the bridge to the future, but for our adversaries, it represents a technological wall they cannot climb. This dominance ensures that if deterrence fails, the United States Air Force remains the most dangerous entity on the planet. The modernization program is a testament to the adaptability of the American defense industrial base when fully mobilized for peer competition. It proves that we can innovate faster than our competitors can copy, staying permanently inside their decision cycle. As we move toward 2030, the skies over the Pacific will be patrolled by a predator that has no natural enemies. To stay informed on the technical evolution of U.S. air power, accurate intelligence is your most valuable asset. We analyze the hardware, the strategy, and the geopolitical friction points without the noise of mainstream sensationalism. If you value objective analysis of military capabilities, verify your subscription status to this channel immediately. Engage with the community in the comments. Is the upgrade of the F-22 the correct strategic bridge to the NGAD era? The margin of victory is measured in engineering, logistics, and will. The Super Raptor ensures that margin remains ours.